Okay, so I'm gonna get started now. The first thing I'm gonna do is just sort of give an outline for how I want the stream to go, so I can like stay on track. I've found before that when I stream, I usually take a problem and I go to stream it, and then 2 hours ends up doing about 30 minutes worth of work because I chat with the chat half the time, and I've got it up distracting me, or I'm kind of not able to fully get my brain in gear. Like there aren't not all the parts working that would normally say like, hey, isn't this going to be a problem and this be a problem later? And those parts of my brain are super helpful for actually doing a good job. But on stream, I'm thinking about talking or talking to people, and so like those parts of my brain, I guess, are busy with other tasks and don't do their job that they normally do when I'm programming. So I'm trying to like play around with the stream format a little bit to figure out a way that I can do good work on the stream and still make it, worth people coming and chatting a little bit. So first thing I'm going to try is I'm just going to make a stream to-do list, which is going to help me stay on track maybe of what I need to do. I'm going to put it on the screen so that you guys can see what is on the agenda too. And if I get distracted talking with chat, maybe you can remind me to get back to stream to do at some point if you're getting bored of me meandering in conversation. So the first thing I want to do is explain the arena problem a little bit. Then I want to, I've got some code in Metadesk, the Metadesk library that's already relating to this. So I want to give you a little look at the Metadesk arena stuff, right? So that's the next thing I would do. And then after that, I'm going to make a to-do list to figure out what we're going to do next. So this is like our major outline of what's going to happen, and then I'm going to sort of build this to-do list out. So after I've discussed the main problem and shown you what's in Metadesk, it'll be easier for me to think of that to-do list then, because I'll have it all in my brain after explaining it, rather than trying to do it preemptively, and you'll get to like see how the ideas of the problem and where I'm starting from today leads to a to-do list rather than me just having one magically off the bat. So like I'll make the to-do list, and once that's done, that's when I'll stop and talk to chat for a bit. So I'm going to schedule that in there, and then once I've talked to chat and found out, answered any questions and discussed anything that might have gone on while I was doing these things, we'll then go and start tackling this to-do list, and maybe we'll put in a couple breaks there for more talking to chat. So hopefully that sounds good. I'm not looking at chat right now, so if you don't think that sounds good, or if there's like a huge technical issue, I'm going to totally miss it. It's just the trade-off I have to make to try to make this a little bit more of a productive kind of programming stream. Let's see how this goes. So first, let me explain what the arena problem is. So if you've like seen anyone use an arena before, it's this very simple memory allocator that linearly grabs memory that's extremely cheap and easy to do allocation and freeing, and fits to a lot of problems. And what I find is that a lot of the times, anytime you have libraries in C that like struggle to stay concise and simple because they're avoiding using memory allocation, so they want you to pass down memory, or they have like memory allocator callbacks so that you can control the memory. It's like this problem in C where you're doing manual memory management, but then that means a library kind of has to have an abstraction of what memory management is, because there's this, basically the way things work is there are two kinds of big pieces of code that you put together when you're making programs, right? So there's other kinds of code in cases where what you're doing isn't actually about the program you're making, but when you're making code that's supposed to like be a tool or an application that you ship to somebody or a game or something, you make like a code base and it has like an entry point. And then the other thing you sometimes do is you make libraries, and libraries are sort of meant to get adopted into code bases, right? So you have a code base that's doing some work, and then libraries sort of are supposed to be sort of dropped into the code base somehow or plugged into it somehow, right? So I like to think about it kind of like blood types, right? So if you know how blood types work, there's like universal acceptors and universal donors. So like a universal donor is a blood type that you could give that blood to anybody, and a universal acceptor or a universal receiver is somebody whose blood type can handle getting blood from anyone. And they're not the same blood type, right? There's like two different points there, and then there are like layers in between of that for different features of the blood type. I think code is kind of very similar. So like at the one end of the spectrum, we have code bases, which kind of want to be, you don't copy paste them and reuse them so much in the way you do libraries. Rather, you reuse them by putting in a new thing that it can do. You have it generate another executable, but you kind of keep reusing the code in place, and you have libraries sort of get donated into the code. And libraries get written in the opposite way. They have to be able to like make as few decisions as possible that might make them incompatible with other libraries and code bases, right? So with that concept in mind, the problem with arenas is that you'd often kind of want, like anytime a library was going to do memory allocation, you would want it to use the arena pattern because it's such a good pattern. It usually fits in with what a library is going to do with the memory anyways. But in C, since the arena is not some sort of built-in type, that means that the library has to write its own arena, right? So this is where I can switch to Metadesc and show you what that kind of looks like a little bit. So let's see here. Didn't work. Project. So I've started sort of experimenting with options for how to solve this problem, but you can imagine that the basic problem here is now I have an MD arena type in this library. And if I also have an arena type in my code base, and then I put this library in the code base together, now I have two different ways to talk about essentially the same concept that are not compatible types. And it just leads to a lot of like friction. You either end up having two arenas getting passed around everywhere that you're using a library because the library's arena is a different type, and you're sort of like using the library's arena to do stuff with the library and using your code base's arena to do stuff with your code base, and then like you'd actually get away with just one arena in concept. Like if it was fully integrated correctly, there's only one necessary arena because you're using them in exact parallel. They're like lockstep with each other at each point where they get cleared together and all this. But you can't go that far because the library has its arena built in. So what we have to do is figure out a strategy basically for what the library could do that would make it possible for a code base to use the arena type from the library without needing to have two separate arena allocators that are allocating out of different memory completely. And, you know, a little bit like more ambitious than that, we kind of want this strategy to be one where if there are a bunch of different libraries that are going to get put together that all have their own way of sort of doing an arena, but we want them to fit together, what is a strategy that those libraries could adopt so that they can all collaborate, even if they have slightly different ideas of what should be in an arena, right? Like what features they need in their particular use case. So that's kind of what I want to work with. Give me a second to take a drink and I'll keep going. Okay. So what I have here is actually in my first attempt at like thinking about how to solve that problem. So the Metadesc arena isn't actually, if you look here, it doesn't have a base pointer, it doesn't have a position or like the capacity that it needs in the alignment or any of the things you might have seen in an arena allocator before. All it has is this arena function pointer. And the idea I had here was that the arena function pointer would sort of be like a one function vtable kind of setup. You'd have a pointer to an arena, or an MD arena, and you'd have no idea what actually you had a pointer to. You'd have, like, it could be anything. And then all you knew is that the first thing at that address would be this function pointer. So everything else after this is like up to whoever created the arena. But this thing was guaranteed to be here so that you could pass in a pointer, like pass that pointer back into the function as well as which operation you want to do. So there's like sort of an enum of the different arena operations that the implementation needs to support. And then the function has like a parameter of type int, which is a U64 int in this case, and an int splitter, which is a union that lets these calls either return an integer or a pointer. So that was my first idea. And hopefully it's not getting a little too in the weeds to explain this, hopefully, but this isn't quite going to work. So the reason that this is going to be busted is, let's like imagine for a minute, like I'm going to start sort of trying to create, like, I'm going to write code into this code base today that I'm going to end up deleting. So I'll call this like exp for experiment, but we'll call this like exp main.cpp for now, okay? So let's say that like here I am and I have like my own arena type. And my own arena type might look like this. Or something, right? And then I pull in this library and I go, well, I want to implement their Metadisk arena type using my arena type so that I can call, like, let's see, somebody who uses the MD arena type in this case. What would be a good one? Give me like an important example API. Okay, so like I want to call parse whole file, and I kind of want to just pass in my arena and like the file name, which I'm gonna have hanging out up here somehow, right? So like, so this would be like, whatever, right? So let's say we had here like a make arena call to, so that would be a real arena. And then we wanted to be able to do this, but of course the problem is that parse whole file comes from this library. It doesn't, since it's a library, it's got to be a universal donor. It doesn't know anything about the code inside the code base. So it has to work on a type that is known before the code base is known about, right? You can't know about the code base inside the library. So it has to take this MD arena type. So what I have to do is I have to somehow construct something that works like MD arena without having to build a whole new arena. And the idea was now we could do this, right? So you'd have like arena wrapper equals MD, or like make MD arena, give you that, and then I can do this. But this is a little better now because I don't actually have a separate arena structure. What I have is like this wrapper thing that has a function pointer. So like what I might have to do here is say that my struct is like this. So it'll have one of these, and then it'll have an arena pointer, and I'll implement that function to make it work. So when I call this here, it puts the arena pointer there, it puts the function pointer there, and there you go. So that's nice, except that now, like, it's good in the sense that now I have one arena. This thing here isn't really another arena implementation. It's this sort of wrapper that tells this one how to work, but it's gonna have some problems. So for one thing, having to do this constructor here is not great. So let me take some notes here, notes about the problem. Having to constantly rewrap existing arenas is negative. We want to try to avoid that. Okay. So this has that property there that it's busted in that way. Like it would work, but it's going to be kind of, it's going to bloat the code still. It's going to have better behavior, but not great. So my other idea was, well, if you wanted to avoid that, now that you've written it this way, you could actually say, why don't we put the arena func right here? So you didn't have to change this in any way except to put the function pointer first. And you can drop this. And then you go and you implement the MD arena function and stick it in here, right? So the cool thing about that is now this actually works. Like I can pass that to there. I'm gonna have to like cast it, so tell it this is in the MD arena or something, which is, you know, that's annoying still, but it's something we'll figure out a way around pretty easily. We could say that this actually always takes void pointers as its interface. So when we are using an MD arena type, we would have that like type def to void so that it has a free cast in there for us or something. So it's like, that's not that big a deal. That's an addressable thing. We could also use a macros to wrap all of the functions. It's a little bit worse, but like we could make it happen. Another option would be to say that we actually do it like this, like there's an empty arena living here, right? So this would have the same exact structure in memory as the thing I just had, and now the type system also works. You just have to, whenever you're passing to one of these interfaces, you have to do this thing. It's like a different way to make a cast, basically. But if the cast made you uncomfortable, there's another option. Anyway, point is, we have these different ways we could make that work. But there's a critical flaw to this one, which is that it's going to mean that if I have two libraries, right, you can imagine here's Metadesk Arena, but suppose there's another library that comes along. It's like, I don't know what it would be called. Let's call it the foobar library. And foobar has a similar concept, but now it's defined as a different type, right? So now that typecast trick won't work, but the fact that they happen to be laid out the same would mean that it could technically work. But what if they weren't exactly the same? What if there was subtle differences, like instead of putting the, this set of operations in there, there was like, there is no set auto align option, or instead of pop2, it has pop amount, or something like that, and maybe instead of get position, it just counts on you to do a push 0 to get the position, right? There's other ways it could be arranged. And if these aren't in a line, then the functions no longer work together, even if everything else about them is the same. And then of course there's like other things could happen, like somebody could decide that they actually need 2 parameters here, and now you're getting into even bigger trouble, right? Like there's all kinds of things that could go wrong when 2 different libraries each define what they think an arena is, and they're not the same definition. So the problem we have is we kind of need something that tells us, well, first of all, it's bad if I can't use into different libraries with slightly different arenas. Okay, so this one is the second problem. Okay, so that's like the whole definition of what is just sort of troubling about this issue and where we're at on thinking, like where I'm at on thinking it through so far. So let me check in on my to-do list here. Okay. So now I need a to-do list of things to try to find a way around this. So this is where my head started going, and I wanted to cut myself off and update my list of things I'm trying to deal with. But where my head's going when I think about all of this is I need this to stay clear of connecting to one library. It can't have the MD arena func or the MD arena. This can't be happening because this is a clear signal that the library MD is now defining its arena in a special way so that the code base has to accommodate it. At its core, right? The core of the arena definition has to include something about the library to make the library work. And that's just not going to be acceptable because that makes it so that the library can only, can't coexist with other libraries that do the same thing. So this is what the arena probably needs to look like. If it started like this, it should stay like this. What we need is to arrive at a way of saying like, okay, I want something like this. Maybe the best I could ever hope for is that I have MD arena equals make MD arena wrapper, right? Maybe that's the best I can ever hope for. And if that's true, we'll settle with that. But I want to study it for a bit before I settle with that because this is annoying to me, and it would kind of tempt you into still passing both around once you went down this path, right? And again, this isn't quite right because you would need to have this and then this or something, right? You'd still have this casting problem actually. Okay. So this is the problem. What we need is some way to define what it means to connect the base definition to the library definition, right? So we have, in my head, what I'm thinking is we have the structure that the library provides, we have the structure that the code base provides, and we need a strategy for how a connection could be made where we define one of these by one of these. We basically create a proof or a path. We reduce this problem down to this guy, right? So we assume this is implemented. We assume that we take on the problem of implementing this, saying that the only way we're allowed to implement it is by reusing these capabilities in this one. How do we create the linkage there without creating all these problems, right? That's the task. So first thing I think is I need to do some getting set up time, right? So I need a quick arena implementation to test with. I need to be able to build my experiment main. Let's see, I can take this stuff out for now. We'll get back around to that later. And then once I've done those things, I want to maybe just run through, I just kind of gave you a bunch of reasons why each of those approaches are bad, but I kind of want to just see them. I want to type it in and feel all the details out, because I'm feeling like I need to pump my intuition a little bit harder about where these things work and where they break down. So iterate through known bad ideas, quick and sloppy work on this one. I don't want to get hung up fiddling with those. I just want to sort of get a quick view of what those look like. So that's one thing I'll do first. So let's stop here and I'll see if chat has any questions or thoughts that I could respond to, and then we'll take a look. Okay, if you are the designer of the library, you could put the onus on the user to allocate and provide the memory. The library only tells the user how much it needs. That's what I always aim to do. Okay, so one idea, I'm going to make notes here too, ideas from stream. Okay, so put the onus of allocation on the user. So we could do this. But this leads to, this doesn't really, I might explain at some point why this doesn't solve the problem. Basically, the reason I want arenas in the library is because libraries that do this seem to create a bunch of problems. When you're making a library for something more complex, where, because what you end up needing here is library only tells user how much it needs. So I'll hold off on breaking down where I've seen this make things way more complicated for now, but this is the reason to put arenas in the library in the first place is that I have my gut feeling is that this makes complicated problems much harder. And thank you for spelling correction in the chat. Oh, nice. Okay. Okay, here's a cool idea. So you can make struct arena md arena work by having each library implementation or something. Let's see, what is this? I'm paraphrasing. Use a known offset within arena. There's something interesting in that, and maybe we'll talk about that more in a minute. Okay, so question, can you give an overview, a 101 on the general structure and how you manage memory? I.e., do you allocate all the memory at the beginning of the program with a single allocation call? Is the pointer to memory shared through a global variable or passing the variable as parameters? What is an arena? Okay, so one at a time. I'm going to start with, do I allocate all the memory at the beginning of the program? That depends on the program. So generally the answer is no, but I do allocate in very large blocks, and usually at the beginning of like certain phases or tasks or processes or something. So a lot of things will get allocated right up front in like large reserved but uncommitted regions in 64-bit programs, and then I will commit out of those in like as I need them. In like maybe I have one per thread or a couple per thread, and then a couple that are like certain like global concepts or like unique concepts that are assigned to the main thread or something. Give me a minute to think. So I think the best way to understand like when I don't follow that rule, though, where I don't allocate everything up front, is that the convenience of how I write the code does play a factor in what I end up choosing to do. So like there are times where if you have to allocate all of the things up front, what that means is that your program has to basically reserve the whole memory space in one go, and then you're just committing out of it. And there's something about that that feels like overcomplicating the problem. Like there are a lot of cases where a program starts up and you just don't know if the user is going to put it into like mode 1 or mode 2, and like that's like the way you want it to work. Like the top level concept of this program is that like you're going to parse some command line parameters and then figure out what you're doing, and that once you figure out what you're doing, you might actually need another arena, so you need another allocation. And so I just let the memory usage, I want some amount of capability for the memory reserve and commit like to scale to how things are being used. And I also I think like being 100% rigid about it unnecessarily complicates it in some cases. There is definitely like, if you're building a game engine, then like the core logic, having that all fit into like a fixed known amount of memory that is taken at the beginning and never released, and then you do all the management within that. That makes a lot of sense, because you, in a game, you don't actually expect memory usage to scale to the situation. You kind of expect the opposite, which is you want the thing to make the most out of whatever its footprint is at all times. And even if like it's not using all the memory, for example, like there aren't that many entities in the game right now, like you kind of want the game engine to be structured in such a way that the maximum, the expected number of entities is a known quantity, and the engine works when there are fewer entities. It's still basically the same as if there are a bunch of them. It's like it's not games don't work super well when you do a whole lot of scaling of the algorithm choice. Like you shouldn't, the way the update tick happens each frame shouldn't change too much based on what's going on. Even though the content is changing, you kind of want the logic to be fairly consistent every frame. It is my experience of game programming. But like other tasks are different, and so like sometimes I do memory allocation in like blocks. Hopefully that makes sense. An arena is just a thing where you grab all the memory up front. In 64-bit land, you grab a bunch of memory up front as a reserve, but not commit, and then it's like a terabyte, right? It's a huge block. And then whenever you do an allocation, you say, here's the arena I want to allocate on, and it grabs some amount of memory. You say like, I need a megabyte. So it'll grab a megabyte and advance a cursor through that one linear spot. Along the way, you can save points where you want to restore to later. So you can say like this spot here, like I guess I should do it. I can't tell which way is left to right for you guys, but like if this is the beginning and I advance to here, and then I save this point and I advance further, I might want to snap back to that point and then snap back to this point later. So you always have to, the limitation of an arena is that you have to free in stack order. Whenever you push memory on, you can't push early memory or free early memory before you free later memory. You have to free in reverse order, basically. But it turns out that matches like 90% of things you ever need to do, and even in that 10% where you don't, there are ways to use the arena without really compromising on the result. You just have to get a little more creative. Hopefully that is an answer to all those questions. Okay, so this is important. So one of the viewers points out, okay, so STB TrueType, which is an open source library that handles memory allocation abstraction. It tries to allow for arenas and other arbitrary allocators by giving you this like define stbtt_malloc size user data macro, right? And if you define that, you can implement it however you want. So you could have that your user data is an arena, and that this is a push, like an arena push of that size, right? So you could do that. And then when you call their functions, you pass in a user data. The main thing I have a problem with here is that this library and most of the libraries that do something similar also have one of these guys, right? So then this gives you like something like this. And the problem is like, you cannot do. Like I just said, you can't make the malloc free pattern doesn't actually fit with an arena. Arenas have the particular limitation that frees are required to be in stack order. So like first allocate, last to free, right? Which means you can't implement free. Instead, what you have to do in stbtt in any library that does this approach is you have to say like, okay, I'll put in my arena, I'll fill it up with all these things, and if the library had a thing that was like going to go and do and manually free all these independent things and save the memory for like intermediates, you're out of luck, because I can't actually free my intermediates. I can't free my intermediates unless I free everything, right? So because the library didn't use an arena style interface to abstract the allocations, it used a malloc freestyle interface, it can't actually take advantage of some of the capabilities of what an arena could do for you. So like if those libraries, if we had foobar here, had like push size user data and then pop like position user data, like if this was like arena style API, then when you have an arena in your code base, the library could do a little bit better job of like using that for you, right? This, you can't quite fit it in, so you have to accept a little bit of slop because the library has chosen a method of allocation that requires the implementer to have more freedom. And the arena is an implementation that doesn't have more freedom. So what I'm advocating for here is actually make the library more universally reusable, because this can be easily just turned into malloc and free, right? Like with malloc and free, you're free to free things in stack order if you want. You can free things in any order, so stack order works. But the point is for the API, like this would have to be like, I don't know, it'd be something like this if we made it work. But like that's a good idea. Okay, good. Also compatible with malloc freestyle allocations. That's okay. Anyways, point is, this is because the API is more restrictive. When the library adopts it as its interface, like for plugins, it actually means that the implementation gets more freedom, because having freedom on the implementation side occurs when the user side has restrictions. So this API says that the user side has the restriction that it can only free in stack order. That lets us use a better implementation. Does that make sense? All right, last question, and then I'll move on. This was super important stuff, so I'm gonna hold on to this one maybe for later, and then the rest I'm gonna clear out. But these were idea. I'm gonna keep this one too. Okay. Okay, so that's a good point. We would have to do a little more work than what I'm saying. I'm not responding to the first thing I meant to respond to. How are arenas compatible with malloc free allocators? To make this actually work, what we would have to do is, since you don't manually pop each one of these, like the free here has to be like decorated, right? So like like my point here was that you can make malloc and free work, but I did a bad job of arguing for it by skipping that detail. So thanks for calling me on it. So this is like what you would do, right? You can make something behave like an arena by just like throwing in an extra node that tracks each allocation. And then when somebody does a pop to a particular position, you just like go backwards. So this is like a next pointer through the stack. So you can make it work. I mean, again, you're throwing away a little bit of capability, I guess. So maybe it's not actually better than this. It's like, which one do you prefer is really more what's going on there. But like the other thing is like usually in a heap allocator, like if you're not allocating, if you're using malloc and free, you don't have this. But if you write your own heap allocator, you already have like memory nodes. So you would just be saying that when you like pass to here, you're gonna like reuse those in a different way or something. All right, so I'm gonna answer the last question I wanted to address real quick, and then I'll get back to this to-do list, and we'll go back to not watching chat for a little while. So the question is, do you ever? Oh, actually, there are two questions here. Let me write these down. I don't want to get on questions all day. So what I'm going to do is save the questions, actually, and then we will address them. Okay? Hopefully that's setup's good with everybody. So let's think about this at some point, but okay. Alrighty, let's look at this to-do list now. I'm gonna pop over here. So I need to actually like set this up so that I can build it and like do stuff with it. So I'm gonna just be throwing in, like I'm gonna break the structure of the library completely today and just get things off the ground. So cl exp main.cpp. Can we add in, maybe I should throw this in the, yeah, let's I guess let's try to use the fork letter project, because then I can use my F key. So let's do build experiment. We'll put, I guess, okay. Yeah, let me pull open the folders and rearrange this way for a second. So source, experiment build. Wait, this isn't the right folder either. Where is, here, I guess is where we're putting them. Right, okay. Build experiment, build experiment. Okay, if I load the project in F, well, I guess before I do that, let's see if I can avoid like polluting the folder with files, at least. So I'm gonna need, do we really not use full paths for any of those? It's weird. Grab the current directory, that should be my source stir. If I do that. Okay. Okay. So let's I think that's that's good. Let's just implement an arena and like make sure it's reasonable. So let's see here. I kind of already have one in Metadesk, so I'm gonna like rip it off a little bit to get us started. Okay. Result. Return result. Let's see. Commit. We have mem commit. We need to go write that function. Okay, let's see, header size, that has nothing to do with how this works. V, align M, new position, align M1, new position clamped, arena cap, new position aligned, arena cap, new position aligned, position footer, so that's talking about arena base, type def, tu8. Just be result. I got to throw in the commit position. Just throw in arena commit size. 1 megabyte. Okay, how are we doing? Partial progress here, okay. We're kind of trying to simulate using the Metadesk library as an outside program to study this a little bit. So I have to like create a pseudo code base basically to get this up and running. 5-minute code base, here it is. We've got a U8, we've got a U64, we've got an arena. Okay, I hit the wrong button. We got through that part. Okay, let's go and write the Windows part here. So up here I have a virtual, yeah, let's do static void mem reserve. Throw in windows.h and user32.lib real quick. Okay, I think that's good for now. Okay, let me do there we go. Okay, so start with just one of these. Let's reserve 1 terabyte. And set the position to 0 immediately, commit to 0, cap to 1 terabyte. And be aligned to 8. Okay. Position clamped up down. Boom. Okay, so I also need to be able to include into this the actual arena library. So what I need to do is take a minute here and like organize this like I would a normal code base. So what that means is header stuff we have to have like, oh yeah, why don't we just do it like this? We're gonna make a real header and actually split this into header, again, I'm not doing this because I'm being arbitrarily picky. I'm worried that I might like assume something is easier than it actually is because I didn't go through all of the steps to actually simulate what a code base is like. So a lot of the times code bases will have like things broken out into headers like this, at least the way I tend to do them. And I'm mostly worried about like creating libraries and code bases that somewhat all fit my style. Like obviously this isn't gonna fly if you want to do like super C++y stuff or something, but like I can do C++ stuff that's not super C++y and make it fit in with other things I've done before if I have a sort of consistent strategy about these pieces, right? So it's a little gonna stick to a C style here, but yeah, point is like this is the way I do code bases, so I'm not going to try to study something I don't know. Like something it's like that aspect of it would just be way too far outside of what I'm capable of bringing to the table right now. But this style of code base I can handle. So includes, and then what we can do is we can simulate including the metadesk library. So including the metadesk library would be kind of like going md.h right here, and then okay, so how do I want to do this part? I guess I'll just say I build in all of my code base stuff. I have my entry point at the bottom here, and then I have library implementation includes here. That's roughly the order the code would happen in. Usually it would actually be the case that this is also not like I wouldn't have includes and then more includes. I would have this in a separate file, but like this is the file that pairs up with this for now because I'm kind of hacking it. But like it should simulate the same effect, I think. I don't know. This might make it more of a mess, and I might want to split it out. But let's see what happens. Okay. So first, I'm not going to worry too much about the metadesk aspect of this. I just want to see that my own arena implementation is like functional, right? So let's make the wrapper macro. Oh, I also didn't do this. Let's grab all the arena functions up here, and then we can do push array right here. Arena type count, type arena push a size of t times c. Okay. So if I want to push onto that arena 1,000 ints, whatever, right? Fill it up with some memory, shouldn't crash. Don't know why I bothered to always make the arithmetic so complicated. How about we just stick with that? Weird habit. Okay, so I also need the ability to run this and make sure it's not going to crash or something. So that's kind of like not, I haven't actually proved anything yet if it just builds. Run. You doing this? Oh, we don't even have it right. It's just built in. Okay. So run. That's going to be like this. Go into there and run experimenting. So in order to actually see that this has done anything interesting, I'm going to have like an additional step of printfing all of these. Alright, almost. I want to throw that into a non-throw panel. Okay. Okay, so I think the memory worked because it didn't crash or anything. The only thing I maybe haven't done is tested if what happens if I go past the first megabyte. So what I'll do is I'm going to pull this out and do this. And then I'm going to say, let's repeat that 10,000 times. That should be enough that it pushes well over a megabyte, right? So that was our size thing, right? Oh, I put that over here. Yep, okay. Oops, wrong button. Build the experiment, run it. Cool. Yep. So it works when I go past that point. Then what I want to do is say, let's build out a little bit more of what this can do. Arena. Yeah. So like usually what I would have is, and this is where I'll diverge a little bit from what I had in the Metadesk library, so I'm not following that. That way I can create some problems in like the differences. So instead of just having a thing that does pop to you, I'm gonna say like, oh, I implemented this. It's this thing here, right? And then those will look like, oops. Those will look like this. Okay, so I think the best way to test that is that it should now create a crash when I do this, because I'm pushing beyond the, oh, it won't create a crash. Okay, I know what I'll do. So first, I'm going to do this thing, right? Creating squares. And then I'm going to clear it. Then what I'm going to do is I'm going to do the same thing again, but I'm not going to clear the temp this time. I'm just going to pull these guys out here. So now when I do this, the push arrays should be rewriting the first part, right? So what I'll do is I'll just have like +1s right here. And I hit the wrong button. So what I see here, yeah, so what I see here the second time should be what I put here, because like if the memory overlaps the way it's supposed to, I'll actually overwrite the original foo array with this thing. There we go. Cool. Okay. So I've got those in there. You can create it, push on it. I think that's pretty complete. Okay. So we can include metadesk, we can use this arena. Now what I want to do is this part here, iterate through the bad known ideas. So what that means is these here, like I want to just see what happens if I try to make this work. Like I want to write the thing that would work this way. So let's see what happens when I do that. So this one is like that. So I have to put it in here somewhere. Like I could put it right here. Let's see, arena. I'm going to call it MD wrapper. So arena MD is going to implement MD arena function, and it's going to have a pointer to an arena. And then I'm going to just pass that right into there. This is where like I have to cast it or something. So why don't we do base? And then to write the helper function, I just do MD. Okay, so we don't have the function for the base part. Then we put the arena right here once it was ready, and that should do the trick. Okay, so this can't be included here. It has to be included after you've already seen the library. Right. You can't put helpers. Pretend this is a header. So you would have your main codebase code, a library, and then some helper code that's not from the library, but that's kind of the bridge between your codebase and the library, right? And this is the bridge code. Then, to actually call the API, you're still not done. You have to invoke the bridge code, because the bridge code doesn't just plug in and finish the connection. The bridge code is sort of like a tool for bridging, but then you have to build the bridge every time you call to the library, right? So that's the downside. Upside is, in theory, we can make this work, and it would work on multiple libraries. So let's try that stuff out. I need to get an MD arena function prototype here. Int footer arena MD func. So So this is going to take these things. I'm going to immediately assume that this is opaque and grab the non-opaque version. I need to switch on this. Up, case, boom, 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 boom. Okay. And the inputter. And then for these, I just kind of go through and do whatever it takes. So for push, I can just call my push function, right? I can do arena push, arena v. Pop 2, I can do arena position v. Push a line. Okay, so push a line is strange, right? Because, like, now I have to, let me write the code and then I'll show you what's strange about it. Arena, push a line. Wow, that's a lot of code. Position. Clamp it and new position. Okay, so what's strange is you can maybe just notice that, like, a lot of what I did, there's like a slight difference, but a lot of this was copy pasted logic. The idea of what this is doing is very similar to the idea of what this is doing. It feels like that concept has not been placed at the right location so that it can be sort of reliably applied and factored out, and that suggests to me maybe I made a mistake by including that into the operation list. Technically, you can do this without a push align function or like operation, because we can get the position and we can do a push. I could actually just combine those. The only reason I didn't do that is because that's two separate calls to the arena implementation. And of course, there's no way to like send down into the function a thing that would say like how to compose two operations. Like I couldn't very easily say make one call into the function so I'm not crossing the boundary twice, but compose get position and push in this particular way. Because it's like you do get position, then you do this like rounding alignment thing, which is sort of like not an operation that's actually visible anyways. You have to put in like get align, I guess. So I guess the main reason it's not automatic is that you have to have the ability to get alignment. And if I did it with a get align, then I have to do 3 calls. Whereas if I do it with push align, the user side only ends up making 1 call through this switch. But now my implementers all have to do this. So maybe a part of the trick is to like put in a helper that makes this dead simple. So you can be like arena position equals MD arena push align default arena position arena align arena cap, right? And it just does this. Let me go throw that onto our to-do list. And set auto align is easy. It looks like that. Set build. Right, okay, so this right here is like the arena wrapper. And I actually want to grab the arena from the arena wrapper. Right? So it looks like this. And then this is arena and defunc. Okay, so that's cool. It builds. I want it to run. Problem is I don't actually have a file like set up here, so let me go read where I can find like a real file real quick. So if I'm in build, how do like the sample programs do their I need to find like an example parcel file that's like actually reading a file. And none of these use a hard-coded path, so we don't actually have anywhere where we just have a sample of like using a hard-coded path into some sample metadesk code. But let me like find one that would be good. Okay, so this is in. Let's see if we can do this. Dot slash. So we're going to be in the build folder initially. Come out to samples, output parse, example.mdesk. Let's see what we get. Actually, you know what the good one would be is just the errors one, right? Because that one I can just print errors and that'll let me know if I get it right. So parse whole file gives me back parse whole file, doesn't that not actually give me the errors to the output stream though? Yeah, okay. Let's see. Message list, errors first. All right, we look at each error and we're gonna print them out. I believe there's a print message. Out. Node, I'm not sure what node kind. Node string, let me go look at what the message has in it again. Let's call those messages to be less confusing. Okay. So I'm going to look at the node, I'm going to look at the kind, and I'm going to look at the string. And see, let's see if that gives me like a clear proof that that the parser has worked. Let's see. Node message. Okay. So, I mean, it kind of proved that it worked, but the error message isn't the one I want. So let me like track down what it would take to make that work real quick. We're in the build folder, right? Metadesk build. When this runs, and if I go back and I go into samples, oh, there's an extra layer of node errors that I need. Let's try that. didn't generate any errors. I guess that this file doesn't actually have errors on it, and it's that, I see. So that's what this is doing. Well, that's fine. That'll work. So weird. What did I screw up there? I don't know. Let's take a look. You know what I should do? I have just thought of something I need to do to break down this to-do list a little more and make it more manageable. Because I'm about to wrap up this first step, I think, and then I wanted to go talk to the chat, but technically the to-do list doesn't say that. We're not actually done with this element of the to-do list. Okay, I gotta go add in debug info. Yeah, let me give my brain a quick break to do a couple easy things. So let's throw in debug info here. Let's go to the stream to do. Construct wrappers inline as needed. Funcputter with arena putter. Single pointer type always works with built-in funcputter. Right, sorry, this doesn't work. I was just updating the to-do list. But now the debugger can show me what I've done wrong. Ah, okay, right. This has nothing to do with our main task, although it is an important secondary task. I should probably add it to the to-do list to actually look at this part of the problem too, now that I think about it. There we go. So in order for the scratch stuff to work, you have to call thread init, and then what I should do is throw in describe the thread init / context stuff and how and what it needs, what it has to do with the arena definitions. Work on that part of the problem. Okay, so there's some like to-dos for later. But with all of these done, I think what I can do is boom, boom. Good. I'm gonna do a full path here, so that we can have an extra step of fun and jump to these. Okay, cool. So I did that one. I'm going to swing back around and do this one in a little bit, but there's a couple of things we haven't actually tried against multiple libraries. is the other part of this. So like we haven't actually tried and seen how this starts to look when we have multiple libraries. But okay, this is all good. I'm gonna stop and do a bit of time with the chat, and then we'll tidy up all this content and like these to-dos, and figure out what the next batch of in-order tasks will be. My brain needs a break. So let's look at chat. Okay. Yeah, hi, Darius Python. I am working on the Autodesk stuff. Sorry I didn't respond. Wait, due to scroll, see new message. Okay, I'm at the bottom. So Mirag has asked, what is alignment for? So alignment pushes, whenever you go to allocate off the arena, you set the default alignment to just say, I want the memory pointers that come back to be aligned on these boundaries. So if you set the alignment to 8, which is what I set it to by default, then all of your allocations, even if you allocate 1 byte, it gets rounded up to 8 bytes basically. Like you take 1 byte and then the next allocation bumps the pointer to a boundary of 8 anyway, so the next 7 bytes get skipped. So it wastes a little bit of memory if you're allocating 1 byte at a time. Usually you don't do that. Usually that's not necessary. But it would if you did actually for some reason do that. It would waste a bit of memory. The point is that it's just convenient. It's like good to have, like you don't technically, like on this computer for instance, I could probably get away with not aligning anything and everything would work, but it's just there are times when when things work out better if things are aligned. I've had like weird things where I was debugging programs that were running remotely, and it came down to the fact that like an integer was aligned, an integer array was not allocated on a aligned boundary, and so it was crashing. It was giving me a seg fault from Linux that I didn't understand. You can also just get like it can cost performance. Like there are SSE and things like that work faster on aligned boundaries or only work on certain alignments. So having alignment as a feature makes sense, and then separately, it means that there's like there's just no surprises about where something like those things, even if the CPU I'm on works, I hate the idea that there would be a surprise based on alignment. So I just like, it's not worth fighting that. I'm never going to be doing something performance oriented where I'm like allocating 1 byte at a time anyways. It just doesn't make sense to let this be a problem. So I just align it. The only time that this would kind of be weird to have is if you were using the arena to like pack memory. So if you were serializing to a stream that you want to communicate over the internet, for instance, or if you're compressing it into a compressed stream and you're allocating like 1 byte at a time because you're doing this like compressed serialization thing, it would make sense to turn it off there. But like I don't usually use the arena that way anyways. Like I haven't found that using it as a way to construct a buffer in order is a particularly useful way to use the arena. It's a little bit too low level. Usually for that, like the buffer can be constructed in chunks, so like, okay, I know the next 200 bytes are going to be this, and then I chain those together, and then I do one final pass to like glue the whole thing together. So I'll use like a linked list or something a little looser to put together the pieces and then serialize it all at once, rather than trying to force arenas, which are really meant to be allocators, to also be like a serialization API. I've just not found a lot of luck doing that, so that's that. Yeah, Darius Python mentions that like there are processors out there like ARM probably, I don't know if this is true, but it sounds like this, it's my understanding that there are just things that don't work on unaligned all the time, and you want to like, I just have been burned by it a couple times, and it seems to me like there's not that much to lose, and if you never have to see an alignment problem, it make your life easier because it's weird to debug. So let me go after a couple of these questions from earlier. I still want to dodge this one because this could be a huge topic that might be worth like answering in a different way, but I'm gonna go into these ones real quick. Is it a possible solution to allocate a library arena from the codebase one so that each library has its own dedicated arena? Yeah, so this was where we started, right? We could say that we just literally define an arena in the library, right? So if I don't have an abstraction for it, instead what I do is I have concrete arenas in each library, and then I just say that, hey, the user needs to allocate an MD arena when they want to use the MD system. that's fine. It's just now I have a problem where an MD arena and an arena are like these two separate chunks of memory, right? I've got a chunk of memory for this and a chunk of memory from this, and I really only needed one, and I kind of am annoyed by the fact that I'm using like the resource usage is sloppy, but I'm also probably more so annoyed by the fact that the code gets complicated, because then you end up where it's very convenient when you can just pass in an arena to like tell an allocate a function what you want to allocate. But when there's like a chain of arenas where it's like you need your base code base arena and a library arena, because you're writing a function that's going to call stuff from the library to extract info and then repackage it and then put that into a different data structure. So you want the different data structure to go on your arena, but you want the library arena to also be a permanent allocator, and they are not compatible types. So now you can't just have one clean context. It's like, here's the permanent allocation destination for things in this function and for all of the things that it treats as permanent allocations, right? You now have to say like, here's the way here are two different definitions for that same concept that are slightly incompatible, and so like it's cruft. That's why I'm trying to avoid this. Yeah, that's the problem I'm trying to solve. Do you ever use something like a frame arena, some fixed size buffer which gets cleared every frame? For sure. So frame arena is pretty good. Like arenas work well in like every context, which is something that's really cool about them. So if you're just writing like pure functional stuff that's not like a game loop or server, something that's got to like keep going and processing new stuff on like in real time or online kind of mode, and instead it's just like you put some stuff in, it processes and it pops out. Even there, arenas clean up a lot of code because they make it composition of functions easier to do in a C procedural style in a way that doesn't incur like weird memory problems, like having to allocate and free something on the same like if you ever write this code, let me give you an example. If you ever write this code, there's something super weird about this, because if you know what malloc and free are doing, there's like a whole search has to happen to discover where to find the memory and keep it, and then like this has to reinsert it back before like to where it was and reconstruct the heap in the way it was before. So a lot of work has to happen here that gets undone here, and if in between there isn't like other mallocs happening, so like this is like a temporary, right? Temp putter. It's like, or an intermediate would be a better word. Intermediate putter. Okay, so if I have this intermediate putter and then like along the way I'm doing other stuff that has to malloc. So let's call this intermediate size, right? If you're doing like this and you're thinking, well, now I can free the intermediate and keep the putter, this is good, you actually still don't need to do this. All you needed to do to cross the boundary from like using arenas to be able to solve this particular thing without an arena 2 is that you recognize that there are like different what's the right way to put it? Like there are, when you have something that is an intermediate that's not going to stick around forever, you can just say, okay, well, you need one thing that's going to be like the scratch, and that one's lifetime is going to begin here. So I'll have like temp equals begin temp on the scratch, and then ends temp here. And so anything that needs to work on on that range of time can go like that, right? So now we've achieved the same thing, except that we've like eliminated the extra work of like undoing the heap changes that happened in malloc, because we're just doing everything like this, right? And then this can happen still on like a normal arena. And it's a different arena. As long as these two don't alias, then this clear here, and when I said as long as these aren't the same arena, when this clear happens, this thing still exists. And so arenas can be sort of like independent stacks, and you're sort of shuffling things back and forth on the top of different stacks and clearing different stacks. So frame arena is a great example of that. You can have a thread arena on each thread, and then separately a frame arena that is cleared at the beginning of each frame, so that you're stacking things up about what's happening this frame and then clearing it. But the really good thing to do with frame arenas is to switch to using a double frame arena, because what you could do there is kind of like if you've ever implemented like cellular automata, for instance, what you generally do is you have two buffers, and you have the current state, and then you have the next state, and you are writing the next state while you're reading from the current state, and then you swap it, and you then make this the current state, and you write to this one to make the next state, right? So at every point in time, you have memory for two states, the one you're constructing and the one that you think of as the previous one. And you never need a third, because you're only ever, the constraint of those systems is that they don't go farther back in time than that. You could do the same thing with like a game loop and have two arenas, and so the state, weird one-off info, like intricate structures that don't really fit into your entity system, that are just like, like an animation that's playing or something. What you can do is have two frame arenas, have the current frame arena build up and like contain state that says stuff about what happened, and then keep that around. So next frame, it's still all valid, and you clear this one, right? And then you build up the state of the game in that arena and clear this one, right? And then this becomes previous frame, and this becomes current frame, and you build that up, and boom, and you do that back and forth. And so you've always got memory to use to fill up the current state, and you can read the previous state. And so what you're doing is you're saying, I'm treating each arena as a different lifetime sort of bundle, a different stack, and I'm shuffling things back and forth onto the tops of stacks. And you can get pretty much anything done that way. Yes, double frame arena is awesome. Glad the answer was interesting. I think it's a really cool technique. That idea is owed to Ryan Fleury. He's the one who sort of discovered this when we were doing the Dion demo last year. It's how a lot of the animations of like smooth transition, like if you look at the Dion, I don't know if you've seen the Dion demo, but if you haven't, if you go look at it at some point, DION systems is the thing to Google. You'll see that it has like a lot of like smooth transitions of like little snippets of code on the screen. And the way he did that is there's like an immediate mode API that generates everything in terms of like laying things out. And then it looks between the states of two frames to figure out where was this thing on the last frame, and gives it a slight update to its position every frame, and then clears that. And so it can animate things moving, like all these different things moving around on the screen, and it doesn't actually store them as like entities. It's just using like states between frames, if that makes sense. Which made the immediate mode API like super easy to maintain. Okay, so there's those questions. Again, I'm skipping this one because I think I don't know, that's a big one to unpack, but it's an important topic because there is something to be said about a library that doesn't make this decision at all. Like the ultimate library would make no decisions and therefore restrain the user code in no ways. But it turns out that to solve complicated problems, you have to get comfortable with some kind of restraint on the user. And I'm trying to find a way to do better than what I've seen before. So that's what we're doing today. But I'm still not fully unpacking that because there's more to say about it than just that. Yeah, let's put together, I'm going to close the chat again, so I'll check out questions again in a little bit. I'm going to piece together a to-do list. Oh, we did this and we did this, so that part is done. Let's piece together a new to-do list. Like this is getting a little bit unorganized here. I want these are to-dos coming from different places, so I want to keep at the top what I'm gonna do, I think is what I'm gonna try. So I put these in here, and I think it'd be cool to get there. In order to get there, we'd have to make a simulated second library arena definition. And then there's a bunch of questions about what kinds of second definitions are there. Really what I want is one that's essentially a copy of the same strategy. I'm not looking for a strategy that could handle all things ever, because that won't exist. But what could happen is I could find a strategy that says if every library were to use this strategy, then the whole thing works, right? Then any reasonable codebase arena that I can think of, in the styles of codebase I care about, combined with this strategy multiplied by n different libraries using it, I should be able to piece those libraries together without a problem, right? And without too much compromise on usability or performance. So I will need this second simulated library, but it's not, I don't think it's that critical. We can kind of like project in our head and think about what a second library might do to a system for a little while here. And we'll do that like as more of a later pass thing. So I'm not going to focus on that yet. Instead, what I want to do, what I might do is like put these in like this. So instead of saying that's under those to-dos, let's say construct wrappers as an idea, and single pointer type with built-in function pointers as an idea. So there's those. I want to do this one, so I'm going to grab it and say, let's copy that up here. I'm going to save this to do like completely for later, so I'm going to actually put this into like a file that I'll actually commit to the code base later. Let's see. Yeah, so let me actually do this part first, because I'm worried a little bit that I might be ignoring an aspect of the problem if I don't. So like when I have the part of my to-do list here that says describe the thread init context stuff and what that has to do with all this, I'm thinking if I'm ignoring that right now, I might actually be like solving half the problem, and the solution I come up with will be overfit to the half I considered, and the half that I ignored will like contain constraints that I actually am not able to satisfy. So I need to talk about that to make sure that that doesn't happen. I'm not sure if I can say work on it. I'll talk about it and then we'll see where it goes from there. I do have another idea. I guess these should go more under. So another idea I have is, what about like, so I have some reasons to think maybe I should just be doing this, and I'm gonna throw that up here as like the next thing to try, and we'll discuss why that might be good when I get to it. Okay. So let's start here. Describe the thread context init stuff. So let's look at md.h again. So this thing right here I had to do a little bit ago to fix a bug. It initializes a thread context. And what that means is like I'm tying a bit of memory to the actual thread itself. So that whichever thread, whenever I have multiple threads all using Metadesk, each one will be able to have a separate thread context that's like independent and doesn't mix and like and get sort of race conditions or other multi-threaded bugs by using shared resources improperly. So what goes into the thread context so far is just a scratch pool. And what the scratch pool is just I think 2 right now. Let me check. Yeah, it's just 2 arenas that I want to be able to grab whenever I need scratch memory. The reason it's 2 instead of 1 is because if I already have one scratch arena that like got past me or something, if I have an arena that I have in hand, quote unquote, like I have an arena pointer, and my plan is to use that as a permanent allocator, so I'm gonna like allocate stuff on it and return that stuff still allocated on the arena, then I can't clear this arena before I return it, because that would break the point of how the arena works. You don't clear things if you mean to return them. But I might, like the arena I'm holding might be the scratch arena, right? If I only have one scratch arena and I write a function that's like, I take an arena pointer and I return stuff onto that arena pointer. If that arena pointer turns out to be the scratch from the current thread, then it like won't work if I also want to use scratch, right? Because as soon as I grab scratch, scratch is gonna clear itself at the end, and they're like both the same arena, and I can't have the scratch arena like accidentally be identical to the permanent arena. So the scratch pool has 2 arenas, just so that if you're already using one of the scratches as a permanent allocator, it can swap the other one. So just like I was talking about with the frames where it swaps back and forth, what happens with scratches and like the swapping back and forth is a little bit different. But at each step, like step down the chain of like calls, what happens is you have an arena and you test to see which one of the scratch pool is safe, or if both of them are safe, you just take whichever one. But then you take something out of the scratch pool and you use it. If that then becomes a permanent allocator to something else in the call stack, like if you go, I guess people draw call stacks going up. So like if the next stop up on the call stack is using the previous guy's scratch as permanent. So it was scratch in this call, but then we have this call show up and it's gone from being scratch to being permanent to this guy. Then when it needs a scratch, it just goes to the pool and gets the other one. And so then when that other one clears, the thing that was scratch in the first place is actually not cleared because it's permanent on that step up, right? So like each step up, it can swap if it needs to, between the two of them being scratch and arena and permanent, so that you get like alternating clears, and at each step you are able to return memory to the caller, and you're able to like make some memory spit for yourself and then throw it away. And just that way you kind of, those are like the two things you usually need in like a call stack setting, like where you're just composing functions. That tends to be what you end up needing, is just the one or both of those concepts, a permanent arena to return memory on, and a scratch. And as long as those two never become identical, that usually seems to work for me. So I'm going with a scratch pool of 2. Hopefully that makes sense. So the only reason this is like relevant at all is because I have to have this arena new function, because I don't have the user pass in 2 constructed arenas and then use those as scratch. I construct them internally. So one part of the problem here that I could start taking notes on, the topic thread context. Should the user pass in the scratch pool already constructed? Question mark. So the advantage to that would be that then I don't have to have an arena new function, and I'm going to explain why that might complicate things a little bit in a minute. The other thing about this though is now the init function like is a little bit more complicated to call, right? So like if I go and add to this that you need to have like an MD arena pool and like a count or something like that, or maybe it's like arena pair or something like that, like if somehow you say that you need that, this function just became harder to call. Something that is sort of a useful like just tool to think about evaluating APIs is that like each parameter in a function makes it harder to call. So the way I tend to think about it is that you're trying to sort of prove that you've done a certain amount of work. So like prove that you've set up memory for a thread context. Okay, once you've satisfied that constraint, you'll let the type system know that you've kind of done that work by matching this type. And then if I put this in here, it's like do the work of constructing the pool yourself and then show me where it is, right? So again, it's one more step of work, but now it means there's another lineup above here, right? So if that's there, then if I go over here to this, then there's suddenly like MD arena T context pool to MD arena T context pool mem2, right? And then like this guy is this guy, right? You see how like this is already getting weird, and then we go, oh well, maybe if we just say like we pass in the arena pair this way, so there we go, and then T context pool 0. Okay, here we go. We simplified it again. How do I get an MD arena? Well, actually I don't have a way of getting an MD arena. I have ways of getting these. I could construct 2 of my arenas, so like I need an arena T context pool. Oh goodness, and now like we have to figure out how to wrap both of them there, but they need to be function pointers after all. Like, you see how this is going to get complicated? Because now I really do need, like, I need putter, etc. Right? I need 2 of these. I need to construct 2 of these, and then I have to, like, wrap them into this thing so that this can be arena MD wrapper T context pool 0 and 1, and then like the putters, because I can't. This won't actually work because this is like now like these and arena MD, and that makes these necessary so that I can do like T context pool 0 dot base, right? So I'm doing that whole thing because we haven't solved this part of the problem either, where I can avoid the wrapping. So, and I have to do 2 more right here to initialize these. So like I added one parameter to the API, and like, look how much it actually complicates calling it, right? Now, some parameters are easier to meet the demand of than others, but like this one I think is really bad actually. So at least so far, I don't think that that's a like tenable idea. That would drive me crazy at the very least. And like the other part of that that's really tough is none of this can actually be like wrapped in a function because it's got to be on the main stack. Like that can't go into a different function that wraps all this work. I could actually pull out the function calls, but like the memory allocation on the stack has to be in the correct location. So that's like not movable anyways. Okay. So that's one idea. The other idea is like I actually feel like I've answered that question, but the answer will change if we end up with like a really easy way to create arenas. If it turns out that I can do MD arena scratch pool 2, and then like this is just becomes 0, 1, and that's it. Like it's still kind of annoying, but like maybe I could be convinced at this point that it's good. Like if this right here is something really easy, then we're kind of in good shape. There's still a separate problem, which is how to make thread context for 2 different libraries cooperate. So we got to do that too, right? Because then if I have 2 different libraries, notice that like then we're talking about this, right? Like now I have 2 of these again, and I might be able to like figure out a way to make this work by going like scratch pool 2, and then this is like the MD version, and this is the foobar version, and like figure this out. But you can see now it's getting out of hand again, right? Really, I kind of want to have the scratch pool system work a little bit cooperatively between my libraries too. So that's a problem to solve. Okay. What else? What else is there about this? Should the user pass that in already constructed? If the user can't pass that in, what's the problem? Okay. So if the user can't pass that in, then we have to have this arena new function. Because then the library will just be constructing the arenas internally. And already like that's gonna be harder, that's gonna make it harder to do cooperation between libraries. Because if each library writes the code that says I construct an arena now, then I have to make sure that they all figure out a way to like know some other library has already done the construction, and bridges between libraries, and like which order of the initialization happens in, changes which bridges you need, and it's complicated, right? So like this might be broken too for the cooperation aspect. But setting that part of it aside, it's broken for another reason, which is, or it's not broken, it causes a problem, which is that in order for an MD arena new function to work, I have to be able to construct one of these arenas. Like the library can't just have a plugin that's like passing in arenas now, right? It's no longer good enough to answer the question, how will this arena work when I pass it to you? I actually have to tell you how you construct it for yourself, right? So if I want to be able to have one arena definition, I'm in trouble. Now, since these are scratches that aren't being shared between libraries yet, it actually worked just fine if these scratches are totally internal and not the same, like visible to the user ever. Like we could get away with that. So maybe that's one solution. Let me keep my ideas going on here. So do we allow scratch arenas to have distinct built-in behavior and never end different, or to have a different definition? I guess, okay, so the reason that's a problem, I'm going to just cross it off right now. The reason that's a problem is that whole thing where you want to be able to, like, we have these functions here where you want to be able to pass arenas. Later on, we have like string manipulation stuff with arenas, string conversion stuff, string to integer, maps, the parser. So all this stuff wants to be able to take an arena to like specify where the memory goes. And that the ability to specify a function that has that behavior shouldn't be like constrained by this like, oh, are you going to use an internal arena or an external arena? Are you going to use an arena that the user of the library is aware of, or are you going to use like a hidden type? So like even if there's a hidden definition, it still has to be compatible if I want to be able to like compose functions in a normal way without writing them all two different ways or something. Okay. So that brings us back to what else can we do about the arena new function thing? If we can't solve it by passing things in, and we can't solve it by making this be like a hidden thing, then the user has to say how, like, this has to somehow be compatible with the type of arena that the user hands to the library. And then you end up in the situation where, like, does the user need to specify, like, how to construct the arena? And I think right now that's what's happening. So let me take a look. Yeah. So right now you like provide the macros for a new and release, and then those get built in however they want. But I think that they're starting, like, I'm starting to get a pretty strong suspicion that there's like a confusion in my head over some of the stuff I've tried. Because there's a difference between something dynamically being implemented two different ways and something being statically constructed in different ways in different contexts, right? So the library doesn't really need to be able to handle 3 different backends for the arena interface at all. What the library really needs, we've done this part. What the library really needs is just the ability to, whenever code base it's in, have that code base statically say how arenas work with it and make that work. So I'm starting to really lean in this direction. Let me do this, because I do think there's an insight there as I think about it. How am I doing on time? We'll be a little bit close to 2 hours. Okay. We'll make progress today, but we won't get through all of this. So if we ditch the wrapper idea, the other thing that could happen is that we bind it in, right, like this. Now, we've already said why this would be a problem, but let's like pretend like we don't remember talking about that. I'm gonna like, wait, hold on. What I'm gonna do is say we can use wrapper method. Arena MD wrapper. Okay. I guess all of this goes into that. Okay. So if I turn off use wrapper method and I switch to use built-in fputter method, then what changes is I don't need, and what's interesting, I didn't have to change the library at all, right? So like these are actually methods of how the code base interacts with the library features I already have. I haven't even started figuring out the library strategy. What I've actually been trying to do is figure out the best strategy for a code base to work with the library I already have. But we're going to get to the library strategy after this, because I'm thinking this reveals why the library strategy I have so far is like doesn't quite work. So if I do it this way, then the arena new has to change to include, oh yeah, let's call it like MD base. MD base dot arena MD func. No wait, this is just func equals arena MD func, right? And then what I do is I have, well, I mean, I have a couple of problems already. So my code base, actually this just doesn't work, does it? Because now my arena definition Yeah, this is a terrible idea. Now my arena definition has to come after all of its libraries that it's gonna like interact with. Right, so like this is why I wanted to like simulate the way I do headers. If I were to try to build this, first thing we're gonna see is like it doesn't know what an MD arena is. And then I have to put this like here, which like totally breaks the flow of things. It's a huge knot all of a sudden. Yeah, that I can't explain why, but that indicates to me that like this whole idea was dumb. So that's not even, we're done with that. Like that is just a total non-starter. Okay. So that saves us some time. We can get right to this one. So it turns out that if you do it the way I was expecting, you can't actually implement the arenas to like plug in. So we need to take a step back and think of it a different way. If we go over here, I had these arena operations, and maybe the answer is instead of thinking that we're going to have like a function pointer and like virtually be able to plug into this thing, what if we just statically do it? Like what if the code base can provide an implementation for the arena, but it's only ever going to be able to provide one of them, right? So the library won't be able to sometimes use arena type X and sometimes use arena type Y and sometimes use arena type Z. It's always going to use arena type X when it's in code base X, but it could use arena type Y in a different code base, right? So that might be the way forward. We put the constraint on that a little harder and loosen up the like problem of like how we construct the actual like layout of memory to create these things. So let's explore what that's gonna do for a bit here. I want to have this here. Right now I have these things, and I'm not sure, like I think I might still need those anyways, but like let's see what happens if, yeah, we won't need this. An empty arena. Empty arena is just going to be type def to void. So it's like a meaningless type that's only there so I can create void pointers with a name to let the user know like that there's a special concept of the void pointer. We don't need arena function or these. Yeah. And then it's up to the user to give us like everything. So let me pull those back real quick. The user needs to give us get position, get cap, push, pop to, push align, set auto align. So we want all of those things to be in the arena like definition block. So it's a lot more static work, but it's actually not going to be all that different because I already had to define each of these. I was just doing it in a switch, and now I'm doing it in macros. Okay. So let's see. The first thing that's going to happen is I'm going to want to fix the library's like own build to see if I can make this concept work. So arena default will still be a thing, but it's just not going to have a function pointer in it. What's going on here? I can just finish. What? Okay, so it's done building. Let me see if there's like a... Do we have something stuck in the on position? 100% CPU. Who's doing that? Who's doing that? Is that... It's probably OBS, right? Why can't I see it? So I'm asking who is taking up 100% CPU, and there's like nothing. Okay, there it is. Okay. All right. Well, that doesn't answer the question. Why is building not working? Okay, there it worked. I guess it just needed like a lot of time to settle down. Okay, so previously I had to make this impl function, and this is basically where the switch lives. Now we're just implementing all of these things. So let's see. It might be useful to like know what the signatures are while I'm doing this. So this is going to be MD64 to MD arena pointer. This is MD arena pointer void. Get position is going to be MD arena pointer to MD64. Get cap is going to be the same. Push is going to be MD64. Pop to that, push a line just like that, and set auto line is like that. Okay, so let me see if like some of these I might just implement in place. Is that a bad idea? I don't know. It seems like a good idea. Whoa. Let me write down some more to do. So what if only the slow path ever triggered a function call and we put everything in the common path into macros? Wouldn't that be neat? Because then like even in debug mode, you get like even better. It'd be even faster than like it already is. It's already crazy fast, but like you could save out a whole extra function call. It might be kind of a reach. I don't know. Sounds cool. So we're gonna say for now that we'll like start building stuff this way. The only thing that's kind of weird about it is you lose out on having function pointers so that the debugger can help you do anything. But for something as simple as like reading the position of an arena or like capacity on the arena, I'm not like all that concerned about it. Here we go. Arenas. Boundary. Line equals B. Because it's not clear where these like things are coming from, so I'm assuming that this is going to match up with this particular type now. So I don't have to none of this is about function pointers or the user specifying it. We're implementing the default that the library gives you if you don't want to provide an arena right now. That might not have been clear. Okay. So the rest of these are, the rest of these do real work. So for now, what I'm going to do is just say, put in a function for them. MD arena default push, MD arena default pop to, MD arena push a line. And then what we have to do is just implement those. So push does void arena default push. Arena size, grab this. This will be arena default. result. Return result. So like what I was saying before about the slow path, it's a little bit weirder because I would have to clean this up and make it like faster. But like the idea was like, what if this if and the result equals buffer plus position and the position equals new position was all together. The weird part is like the alignment has to get applied, and so like I'd have to make this fit into a macro, which like would not be that hot, but it would be kind of a lot to actually dump. Or I mean, you can't skip it either because if you don't, you have to either align before or after the push. Like you either take the position, align, and then use the aligned thing as the result, and then add, or you add first, return the current position, add first, and align for the next user, right? One way or the other, you have to do align work during a push if you keep like a default alignment. But like the align isn't that much compute work. This makes it more complicated than it needs to be. I could get rid of that. Yeah, I'm curious about that like direction as a thing to explore, but I'll keep it out of my head for now because it looks like I can't quite get there without. It's a bit of reach, so if I think about it too much, I won't make progress at all. Yeah, I screw those up in the implementation anyways. That should actually take a boundary parameter. Okay. So, how does it feel about that? It still wants to set the function pointer. Cannot open program database. That's going to take a while, I think. It took a while last time. While I'm here, let's cross off this. We're working on this one next. Okay. Yeah, so you don't need that, do you? You just need that. Instead of V, it's called size now. The rest of the implementation can be this. Doesn't work. So this is where when it's on stream, it's really tempting to like look at chat, and since I don't have it up, I can't like lose 5 minutes probably going down a thing. I just give it 30 seconds and keep going. So that's just result. This is like unbearable, the fact that I have to Okay, what I'm going to do is say, let's use like 1. So this becomes just like md impl arena push, right? Oh, I didn't put arena in the names. That's silly. Let's do that. So then, yeah, this means like I originally wrote this with this like extra wrapping layer that like turned the low level like abstraction into a normal API for the library, but now it's like 1-to-1, more or less. I guess it's not because begin temp, end temp, still a little bit, yeah. Okay, let's keep it the way it is. I won't overthink this part. I might clean this up later though when I think of a way to do it. What was I doing here? I was doing get position, right? So this just goes to get position, arena, temp, and well, let's just do this. Cool. Yeah, so that like literally no function call there now, which is an improvement actually. So actually, another thing that's cool about this is like if you did want the library to have the ability to handle multiple backends, you could just statically attach an arena implementation that does that, right? Like the cool thing about like statically overriding something is that you can statically override just once, which is a restriction, but you could just statically override something to use a dynamic override. And it's like just as good as if it had been dynamic in the first place. So this is kind of more fundamental, I think. A more fundamental way to set up the override in this case. Right, okay. So there's a little bit more work to it because I don't actually have the correct type, like on the arena pointer there. Come on. There we go. Here's the arena. Here's the position. Now the functions are taking a default arena directly. It's a little bit busted. So these actually need to take an MD arena and do the cast, right? Even though they're an implementation detail for the arena. I mean, the other alternative here Okay. A couple of interesting ideas. I could wrap it in the macro. So the main thing is, like, if the user just has a function that matches already, like, it's annoying to have them worsen the function's details so that it'll fit the macro usage, right? Like, this is expecting an arena pointer, not an arena default. This will work when you pass an arena to it that was actually an arena default, but the type system won't know. And so, like, we need somewhere along the way somebody to give up, right? Like, either this side has to do the extra cast and say, like, hey, my users deserved to know that I only work on arena default, but, like, I had to give up. Or this side has to give up and say, like, I have to, like, have a md impl arena type, like, macro so that I can give you the cast. Or the macro has to do it and say, like, oh, I can't actually just be simple. I have to do this. Like, I have to do the whole thing so that I can do the cast for you. Either way, somebody somewhere is doing this annoying thing where it's like extra typing to bridge the divide. And I'm trying to think of, like, what's the way to do that that isn't annoying. So, like, the trick would be if you could define what MD arena means from the start and say, like, look, MD arena is always going to be used as a pointer in the API, so it really doesn't matter what type it is. We just want you to tell us what MD arena means yourself. But then the problem becomes that it's not until I include the .c file that I actually have arena default defined, right? Like, usually this is fine. We just have the headers come first, and then the codebase headers come first, and library headers get dropped into the codebase. So the codebase then, like, has the ability to define its stuff first, and then the libraries will be able to see those things, and we can, like, hook things up preemptively if we need to. We can do we can do bridge code before or after the library as according to what the library wants. But in this case, it's a little weird because we also want a default, and the default would have to be in the header, and then the header would have to be the spot where we do some of the decision making about which defaults to apply, which we were trying to consolidate into the C file. So, like, let me go write down what some of those options I just discussed were, and we can keep going. So if we do this, then we have to think about, could we define MD arena as a bridge what about MD arena default in MD.c? Right? This would be cool, except that then this breaks, and so we either have to give up this or we have to modify this. If we don't define MD arena, then the function APIs here just take in a thing that is an arena. Like, it's got a defined type. We can't do anything about the fact that the type info is missing, essentially, at this point, and the bridge comes afterwards. So if we do a bridge afterwards, yeah, so since these are like this, I think what we could do is we could put in a post bridge and then say, yeah, okay, let's try this a different way. I think I've made my decision. Let's try and construct it where the person who's constructing the bridge doesn't have to do any work, and the library does the work, right? The library is trying to be helpful. The bridge is constructed by the codebase maintainer. The codebase is constructed by the codebase maintainer. Let's have the library carry the burden. So what's going to happen is whenever we call one of these things, we have to like do like an MD impl arena pointer thing. And then it's your job to tell us in the bridge, along with everything else, what an MD impl arena is. So this is like a type. So if you want the default, then what happens is we just define that MD arena MD impl arena like that, and then these other impls here can just act like the arena will have the correct type. And the reason they can do that is then we just go through and say like anytime you've got somebody calling this thing, yeah, we gotta update these. Anytime you got somebody calling this thing, they're gonna have to like do the cast work here inside the library. I think this is probably the best way to avoid, like somebody has to carry the burden, but like this is the one who should, is basically what I'm saying. I think this is better than trying to avoid the burden altogether in this case. How am I getting lost here? What am I doing? Okay, arena get position. Arena get cap. No, we just look for arena push. So you see what I'm doing is like everywhere that I call an impl, I have to manually do the cast. And the only people calling the impl, like now there's a reason again why these exist, which is just to wrap the impl calls. The library does that work. Okay. Let's try that approach. Arena set align. Whatever. I'll have to clean up the naming scheme, I guess. Arena V. Push align. Arena clear is just a wrapper for popping to 0. Arena new, arena release. Let's see how that goes. Oh, good deal. So I think the library is back. So then to finish this up, I would just need to go and try and do it in the example program. Okay. So what is it like to do that here? You don't do that. We don't do that. We just pass this in directly because MD arena is actually a void pointer, so it should work. Okay. So now the only thing is it won't actually work because we have to fill this in still. Where is the, give me this thing. So in order to define the arenas, I need to do this work. So this is going to be my arena type. The way to make a new arena pointer. Oh, that's interesting. So a problem this raises is now the code base likes to return arenas. Yeah. The code base likes to return arenas in this particular way I set it up as non-pointer structs, and this wants it as a pointer. Right? So we do need like a little trick or something here that's like arena so like, okay, there's like two ways to go about this. One is I can make one allocation and put the arena at the beginning of the allocation. So an arena pointer is just a pointer to the beginning of the whole block. I do one reserve, and the beginning of the reserve is where the arena's data structure goes, and then the rest of it is for allocating out to users, right? And that's how the MD arena works, and that's why it expects to like get back pointers and always deal with pointers. The part of the idea was like, let's only have one type. We don't have a distinction between a handle and the data structure itself. Like you can't accidentally copy an arena data structure and like have two different structures referring to the same block, because the block, the structure itself is in the block, right? So that was the idea in this one. And if I'm this one, if I'm this guy over here, now I have this weird problem where I actually have the block lives outside of the, like the block and the data structure live separately. And that's fine, I can just give a pointer to this, but I need to be able to tell the library how to do arena new, and this was sort of like, I guess, what I anticipated being weird about this. Now I need to be able to construct an arena for them, and that's a little bit different than just being able to implement everything else. So what I'm going to do is like hold off on that one and hold off on release, and we'll go through these other ones real quick because these should be the ones we can actually do. So let's see here. Get position a position. Get cap a cap. Push arena push pop 2. Here I want to like do the pop 2, so I'm gonna have to implement a like extra step here. Arena pop 2 arena position, and then this is going to become arena pop 2 temp arena temp position. And the reason for this is it being like that and not like, I guess I could literally just do the macro in this case actually too. I guess that wouldn't be that bad. Since I'm controlling the bridge, I can always fix it later. But the idea is, in the long run, you might want to do stuff during the pop besides just setting the pointer back. Like this is super fast free is awesome, but there might be times where it makes sense to like equip your arena with one other feature, which is like a stack of pointers that you want to check whenever you do a pop, or like clamp the position or something here. Like the pop is the opportunity to like do other stuff if you wanted to make your arenas more complicated. But maybe that's a bad idea, and I should just do this while it's, at least while I'm not doing anything fancier. Push align. So I didn't like go and implement push align and those guys. I can do this one. Align equals B. Let's do arena push align. boundary position cap clamp position. Okay. So there we go on that. Okay. So let's talk about this arena new, arena release part now. So the way I could make this not be a problem is if the memory, yeah, it's weird. If the user has to return this as a handle, then like they have to have a way to construct an arena and give you a pointer-sized thing that completely describes the arena, which means that like if you're used to constructing an arena that's wider like this, you can't use this, right? Now what I could do is just say like allocate a different page, put the arena there, and then go. And so like this could actually, I think, be adapted to work like this. I think it would be possible. The other thing we could do is switch to an init style. So if this was arena init, then what happens is that this gets passed in here. Somebody else has the MD impl arena in their like on the stack or in some memory somewhere, and we init this way, right? Like you get the spot where the handle should get constructed, and then like if you wanted to do the thing where you do it like the metadesc library where the handle to the arena is the first byte of the reserve you made for the arena, then you just make your impl arena like a pointer. It's like a double indirection when you get this, because you would get past a function pointer, like a pointer to a pointer, and then you'd fill the pointer that you take the construct the pointer you need and write like do the right thing, like you know that would just work. So you could treat your arena pointer as the actual impl type. And I don't think we're using our MD impl arena in such a way that it couldn't be a pointer itself. And then for the user who doesn't have the pointer, they could then write this more like this, right? Like arena init is just where you get an arena, and then you get like, in this case, you get the U64 to the cap, and you do this work. Right. Now, the only reason I'm not super enthusiastic about that is I think this just brings us right back to the problem we sort of were worried about in the first place with arena new, which is, yeah, who's going to construct the memory still? When the memory for the arena is a part of the arena new function, then like this thing here doesn't have to ask the user for memory, right? So basically the question is who's going to give us memory for like that's it. That's now I get it. One way or another, whatever we do, someone has to set aside memory for this stuff, right? If it's the header of the reserve block, then the person setting aside memory is the library, and the user doesn't have to pass memory down. If the thing setting aside that memory is the like this call here, it just won't work because this call here can't do like MD impl arena memory 2, because now the memory is like on the stack of this function and will like get lost as soon as we return. This is supposed to initialize the thread, and so like the caller of this needs to assure us that like we have the memory. So then that's the next step, is like we could do this, but now we have a problem, which is, remember, I don't want to put my macro overrides into the header. Maybe if I gave up on that constraint, I could do this. But the other thing I could do is say like, you got to provide the arena memory, and like we got to do this in an unsafe type, like a non-type safe way. You just give me the arena memory, and I'm going to trust that you're doing the right thing and giving me memory that's big enough for me to init 2 of these or something, right? So that's an option. what doesn't seem to be an option, well, another thing we could do is say, like, if we knew how big this was going to be, like, this could be, yeah, so this only works as it is. I can only really put the memory into this struct if I know that a pointer is big enough, which is what I was counting on here. And then no one has to pass down extra memory to make it work. No one has to like figure out how to allocate some memory for the arena headers here. We just say that your arena header has to be a part, like has to be allocated and set aside by the same function as the one that initializes it. And like, I don't know, super torn on it. Let's see what happens if we try this. Okay, like, I feel like I'm being theoretical about something that I haven't fully tested. What if I have arena new, and I have like arena new like, I don't know, what is the layout here? It's like, header method, I don't know, methods and over header technique. Okay, so if I decide to have my, if I have my code base written this way and I switch it to writing it this way, then how easy is it to make that work? That's the question. So I do like void memory equals memReserve. I'm going to need to know the size. And so then what I'm going to do is I'm going to say they're asking for some amount of memory. Arena new. They're asking for some amount of memory. What do I do here? Do I add a little bit? Because if I do like size plus size of arena, then I know I've got what they're asking for plus enough extra, but that's actually going to be like a whole page extra. So then the next step is like, well, what I really have to do is go like size up equals whatever they're asking for plus a little bit more. The other weird thing is like they don't actually need what they're asking for. This is like, what scale do you want? Do you want a gigabyte? Do you want 64 megabytes? Do you want like terabyte? And if you lose an arena off the front of that, maybe that's just like, that's fine. Like maybe the rule is like you ask for a certain size, but the implementation's allowed to take some amount, and like you gotta just manage that yourself. Like keep this within reason. We could even say that there was a rule of like this should be less than 64. Right? I think that's right, fair. Like your arena type should like fit in 64 bytes. Okay, let's do that. So we reserve this, and it's understood when you put that in that if you ask for a terabyte, 64 of those bytes are for the header. And then what happens is we get like the main base, which is just going to be what happens when you take the memory and add in 64, and you get the arena at the header of that. The base comes from that. The cap is just the original size minus the 64. The align is 8. Cool. And then the next thing is you got memory result. We gotta like before we can write to these, so this is only reserved, we have to like commit some amount. So let's commit the first, we already have like a commit size that we're going with here, right? Like, yeah, arena commit size. Yeah, so we'll just arena commit size onto the results, or like onto the memory pointer, some amount right up front. And then what we have to do is we have to like set the arena commit equal to the commit size minus 64 as well. That's super weird, right? Because like now, You see why this is weird, right? Like this is now saying that the commit is not going to be aligned, which is going to lead to like this not working at all. So I can't quite do it like that. It's also going to mean 64 bytes is like the only alignment it understands. So, okay, that leads to some problems, but let's take a second shot at this. Here's another way we could do it. What if instead what we do is we first rely on the non-header technique. And the reason we're doing that at all, the reason we're even bothering, is we're trying to figure out how to build the bridge. If I decide that using this header technique is better, I'll just write all my code bases that way anyways, and it won't be that big a deal. But I have a bunch of code bases written that don't use the header technique right now. And if I'm going to use libraries in those code bases, I want to know that I have a bridge figured out for those code bases. So I'm like figuring out what the bridge needs to look like, or what options I have for the bridge at the moment. So yeah, we'll adjust this to take in the size. That's easy enough. Okay, so you just take that in, and then what we do is we say like, you gotta push an array onto that arena of one arena. And then what we do is we say, like, what if we just transferred all of the information onto that arena? So now if someone ever does pop to 0, we would have a problem, right? But we could fix that. We could make that okay. We don't need to like say pop to 0 is legal. What we can say is that like the reason this should be allowed is because we returned to you an arena that already had stuff pushed on it. You're not allowed to like do arbitrary pop tos. You can only do a pop to a position if you asked for that position previously, right? So like the idea would be this. We have this get position thing, and what we're kind of asking is like, if you're gonna, you can break the rules and figure out like Wild West what happens, maybe try to squeeze something out of the system. But if you don't want to break the rules, the rule we're gonna ask you to follow is the only time you do pop to, you use a position that you got from a get position, right? So instead of like, you can't pop to a random value you think of, like 0, you have to do a get position, and that get position tells you like a point where the arena is currently at, and now it's legal for you, since it returned that to you, that's like a legal waypoint that you can use as a pop to value, right? And then once you do that pop to, it's like no longer illegal anymore. That and all the ones you got after that become illegal again. So in stack order, you're basically like grabbing a handle. The U64 is the handle to this position in the stack, and it's now a legal idea that you can pop to here, but if you never got that position back from a get position, then it's like you might be causing a bug if you do this. So then then pop to 0 is a bug because you like, at least in the general case, right? It's only if get position return 0 would get pop to 0 be allowed. Hopefully that makes sense. Let me think about that for a minute. So it solves our problem. It means that there's a way to incorrectly use the impl API, but the impl API is totally internal. So the only people who have an opportunity to misuse it are the maintainers of the code base, which makes me a little bit comfortable with this idea. It's a little bit of a technicality, potential for screw ups and bugs. We have to tweak something about the API already just to make this work. But I think it's okay. So the only problem is like, usually if I'm talking about building bridges here, I already have like an arena clear. It's essentially the same thing, position equals 0, right? So what do we do about that? Like, it seems like that just ends up creating the same problem, right? The only way out of this is if like an entire commit section is reserved to the header, which is way too much. because you see what I'm getting at here. I'm trying to explain this to you, but I'm also like thinking it through, and I'm just exposing my thought process. What's going wrong here is that we're trying to figure out how we'll be able to construct bridges between the library strategy and things that are already in existing code bases. And existing code bases have this. That's just a fact. So we need a bridge strategy, like a bridging strategy and a library strategy that will kind of work with what's already out there. And then I'm looking at this and thinking, this technique would let me convert a non-header arena into a header arena with only this function, except that now like this will break that. And I need that to not be a problem, because in addition to this being used to like create the scratches in the internal stuff, I'm gonna add this, right? Because I can't use, I'll explain this a little bit in a second. So I have arena get position pop to. So I have right now just assumed that pop to 0 is how you clear. And I would actually need to like change it here too, to like call a clear function, and then clear functions would have to know things like you don't go to position 0 ever. So what we could do is say that it's not, yeah, okay, I got it. Arena clear isn't the way to do it. Okay. So what we do is we keep this, but we change that, right? So md impl arena min pose, and then I pass in the arena. So the idea would be you have a thing that lets you ask what's the smallest position, and you can do that, right? So like you can always pop to that. And popping to it is equivalent to clearing the arena. And then, yeah, we just got to track down, set auto. Set auto align min position of an arena. Min position of this arena is, hey, I already did this 64 byte. That's literally the thought I was thinking before. Arena default header size is like just what we return. We don't actually even need to look at the arena pointer, but we'll let the API allow it in case they want to like dynamically change it. Okay, and then, so this will be fine because although they'll have the ability to do an arena clear on an arena pointer and cause a bug, if they do it on an arena where they set this up, they have to figure that part out themselves, right? So the point is the bridge now lets you like pop this up and start working. It doesn't totally solve the problem, because if you construct an arena this way and you have this in your API, then you have a problem. But our API will never call this. Like the library won't expose the problem. You'll be able to like integrate the library on day one, get it up and running, and then go, okay, because of that fact that this prefers header technique, we have to go and like take out the like update the way we do clear. Okay. And like that way you get like day one easy integration, and then you just have to generate a to-do list of like updating your arena implementation before too long. And that I think is okay. That's pretty good. Like it's not perfect, but I feel like it's better than all the alternatives. It's the best I can think of so far. Okay. Just double checking the assumption that that's true. Maybe it'd be easier to just pass in the memory and do the init style. I guess we should try that. Let me put this on the stream to do. I don't think that one would work, as I've already figured out that we can't really do empty arenas inside of the arena. Thread context, simulate exactly what about define empty arena as a pre-bridge. If that doesn't work, we already figured that one out. So, okay, after we figure out this thing, then another thing we want to think about is, should we do arena min position, or to implement clear? Should we do arena clear on the header technique problem? It instead of you. Pass in memory with web context. Right, so there's some ideas to try out. Okay, so I can do header technique, min position. How does this look? Redefinition, right, so I gotta turn off default arena so that I can define the arena. Okay, right, I gotta implement this. So, arena release header technique. Like this. So, if you create a header via header technique, then you should be able to release it with just a pointer to it by going mem release arena mem serve release. Let's pop back over here where I have an example. Release. Impl release. Virtual free. Load footer size. And release. Cap. What am I missing? There we go. Hey, it ran. Okay, so I'm gonna check out chat real quick and see if there's much to talk about, but I'm not gonna go right away. I need to take a short break for my voice, stretch my legs, and then I will respond to anything that I saw. But first I'm gonna take a look and acknowledge if I see things or not in the first place. Yeah, looks like we got some cool conversation going on here. Looks like there was also maybe a hiccup in the stream. Sorry about that. Yeah, these are good questions. So I want to come back and answer these, starting from something like an object in OOP. Would that solve anything? Sounds like we have to keep a lot of different arenas and pass them around. I will be back and discuss in a minute. Okay. Yeah. Let's talk about some of these questions. So, the first one, I wonder if making the library be stateful, something like an object-oriented technique, would solve anything. Sounds like part of your problem is that you have to keep different arenas and pass them around. At first glance, every single Metadesk public API function takes in an arena. Does it make sense for those arenas to be different ones? So the reason, yes, the problem is that there are different arenas and they have to get passed around, but that isn't like, I'm trying to figure out how to like put this. The problem is who owns the definition of the arena, not which techniques are used to define it, right? If the Metadesc API uses object-oriented style or functional style or any other style, no matter what style it chooses, it's going to define what it means by arena. If I have a code base that also defines what it means by arena, whether it's the same style or not, they're just not compatible, right? There's no way for two things which were defined without either of them knowing about each other, even if they're in the same language, whether or not they use similar styles or different styles, similar techniques or different techniques, they just are incompatible. They are not the same type. And so the closest thing you could have to making them compatible is if they happen to be like one for one, they have the same fields in like the same functions and everything's the same, you might be able to build a bridge between them that's like just using one as the other and like casting it and pretending that it's not a problem, right? But the point is, how do we get to a situation where we're in a language here, C, and we're saying, and C is set up in such a way that there's no default arena to like type or definition or thing that like binds libraries and code bases together, right? So there's no way for them to like agree ahead of time what they're going to do, right? We could define a standard and say everyone write to the standard, and then libraries will take in that standard arena type and code bases would implement that standard arena type and pass it to the libraries, and like everyone would have the same standard arena. And what that's essentially going to lead to is like a dependency problem, right? Where you always have this arena type like that you have to defined before everything else. It's like it's its own library basically, and as its own library, all these other libraries are depending on it and these code bases are depending on it. I kind of want to keep the structure flat. So there's code bases that don't know anything about other code bases. They only know about other libraries. And the only way that they know about other libraries is not like they know about them ahead of time. It's just once we decide to put a library into a code base, the library has to be like compatible into that code base's structure, right? So you have to be able to integrate the library into the code base. Libraries get written with a vague notion that there are code bases out there, but no idea which ones are which, and they never find out. A library should never find out about the existence of code bases if we like keep the division perfectly clean and never like use any hacks to get the job done, which sometimes happens. But like if we're trying to be disciplined about it and end up with a library that is written like a library, it shouldn't know that there's like this code base that I'm going to be a part of later, right? And furthermore, it shouldn't necessarily matter like which libraries I put together, right? I should be able to grab, here's a helper, here's a helper, here's a helper. They all have arenas in them, in the sense that they all define code that like operates in the presence of arena allocation that is explicitly parameterized, like that style. I'm saying like let's go ahead and say that we're not going to solve incompatibility with everything, but let's like say suppose all these libraries had decided their style was going to be explicitly past arena allocators. Then how do we make it compatible for all those libraries to be pulled into one code base and not have to have a separate arena for each code like library, right? And at the same time, not ever have to have a library that knows about another library. Like I don't want to have Metadesk know about the arena library, for instance. So if a library has to be a self-contained, no dependency thing, and a code base can have library dependencies and nothing else, how do we make it work? That's the challenge, right? If the answer is something like use an object-oriented style where you would override the virtual function, that's like what we've been exploring actually. That was one of the things we've tried a couple different ways. And as for the question doesn't make sense for those arenas to be different ones, there's a parameter to the functions because the question doesn't make sense for them to be different doesn't really make sense. It's a function that like a lot of the time it will use the same one, and occasionally we're going to switch it and use a different one. And that's because there's like multiple arenas that manage multiple sets of lifetime. It's not so much about like this function will get this arena and that function will get that arena and that function will get that arena. It's like all of these functions want to be able to take arenas, and they'll take this one a lot of the time, they'll take this one a lot of the time. So yes, one function would be enough for us to say we might have multiple arenas, but separately, we don't want to have like the reasons to have multiple arenas should be things like I have multiple, like it should work out like this, right? It should be that I have multiple arenas because I'm managing separate, like their lifetime separately. If I have two arenas or multiple arenas whose lifetimes are all connected, like they all start at the same time and then clear at the same time and reset at the same time to the same points and all that kind of stuff, then they shouldn't be separate. And the problem is that those still have to be separate when they're from totally separate libraries that are just constructing the arenas like concretely in their own definitions, right? So we can't have each library implementing its arena by defining it concretely and make all of this like compatibility work. Alright, so there we go. I think I'm up to date on chat stuff. Let me see. Oh, there we go. I'm up to date on chat stuff now. Is that stuff making sense? I'm take another minute to see if chat wants to respond or think about that. I was gone for a bit, so I might have lost some folks. I don't actually know if we even have an audience. I haven't been keeping an eye on anything like that. I don't even know how Twitch works, so I don't know how I would keep an eye on that, but yeah, I'm kind of running out of steam, so I think we've gotten pretty far today. The main thing we figured out is that I think statically doing the override is smart. I think that like the idea of the virtual function pointer type thing or the switch, I thought it was neat. And I also like thought that was unnecessary. Like I thought that would go well with the idea of the header technique, and I think actually a header technique is good, but the function pointer is bad. I think that like I should be converging on a header technique and also converging on static overriding protocols for things like this. Because yeah, I don't know if you the argument that like with a static override you can always statically override it to have a dynamic dispatch is pretty compelling to me, because that like means that static overrides contain more possibilities. They contain the fast possibilities as well as the like dynamic slower possibilities, right? You can use a static override to dial in the performance or to dial in the flexibility at runtime, which I'm still not sure why you would need to do that. But I think the goal would be that we only ever have in each code base, like in each compiled program, one concrete definition of an arena, and everything else like flows through it. I also think header technique is pretty smart. Like I'm pretty convinced by that, because it eliminates a couple problems with the arena, and especially with the function pointer removed from it. It makes a lot of sense. The only issue is that I have a bunch of code not written in header technique. and like I have to watch out for the ways that's gonna cause issues in the transition of the style. This problem is interesting too. How are we going to share the scratch pool? Like, how are we even going to share the thread context? Right, so I'm thinking I'm out of steam to write any code, but let's like, I might just wrap up stream by, I think what I'll do, okay. I'm going to hide chat and I'll look at it one more time before I close if there are any more new questions. But here's how we're going to wrap up. So I am going to think for a bit about the thread context stuff. And then I'm going to package up all of my to-dos and lessons learned and ditch the intermediate to-do lists so I can continue from here later. And we'll go back to chat. All right. So let's think about this thread context thing. How would we share the scratch pool between multiple libraries? So like, let's think about like literally what that would take. So all it means if we share them is that like there's a block and there's another block of giant memory, and there's like some position in each one that we're keeping track of that's like where it's at. And then when we're going to grab scratch from the a scratch arena from the scratch pool, what we want I'm starting to get an idea, but what we want is that like you end up with a handle that lets you like allocate out one of those things, and then you have the ability to make sure you're not using the same arena twice for two different purposes, and by doing like conflict resolution in the get scratch call, right? So you can like say, I don't want something that conflicts with these arenas, and then it gets you one that doesn't conflict. So what we want to end up with is that if we have multiple libraries and a code base that all define their idea that they want to get scratch, they say, I want to be able to get scratch. And what they mean by that is like, I want to be able to get like a pointer to that type that I set aside as like the thing that represents an arena. So like in the metadesc case, we want to be able to get to this MD arena pointer that happens to point to a thing that we can treat like an arena, right? So like in particular, what I mean is a thing which is compatible with these macros, right? So how will we guarantee that they get one? Well, and like at the same time, how do we guarantee that they how do we guarantee that they would all have, there would only be two of these on the whole thread, no matter how many libraries showed up, right? So like right now, my code base will have two of these chunks, and then the metadesc library will have two of these chunks, right? They'll each have two of these chunks, and they'll have their own scratch systems. So like the easy way to do it would just be to say, the code base will set up a scratch system, and the library needs to like use that scratch system, right? Don't set up a scratch system and then try to share it between libraries. The code base creates the things that get shared between libraries, and the libraries simply request for those features to be made available to them. I think that's kind of where things are going. So like in the case of Scratch, it would mean this. We need like a get scratch, right? Then what happens is it's a little weird because we don't want to force the user to implement get scratch. If they're dropping, like we want the library to be useful in those big code bases, but we also want Metadesk to just be a drop in from the sky into like a brand new program, and you're just off the ground and the defaults take over, right? So we also need a default for it. So the real problem isn't how to make them all plug together. It's how do you make that so that you have one way where they can, all the different libraries and the code base can plug together and use one scratch. And at the same time, they have a default scratch that's available to you. And what's like the way you want to set that up? That's the question I need answered. So should like the default scratch should be turned on by default, and then you have to manually turn that off in each library. It makes sense that like that's how it would work, because if you don't do it that way, then the scratch isn't there by default. But it's, I guess, like what you'd have to do. You have to build the bridge to the scratches anyway. So like what we would end up with is in this over here, we'd have like, I tell you, don't use your default arena. Here's the bridge, and then don't do your get scratch default stuff. Here is the bridge for that, and that's just like, I don't know, like I have OS get scratch or something, right? I don't know. It's a little weird because you'd have to like take a look at what, I guess get scratch needs to return the MD arena pointer, and then like the get scratch function. Yeah, so what we need is to factor out the part where we figure out the arena pointer. Once we have the arena pointer, like they can do whatever they want. If they want to wrap it in a temp, fine. But what we need is that the get scratch implements the part where you go from not having a scratch arena pointer to having one. And then the default does like this loop with the conflict resolution for you on like a default thread context, right? And this is like all of this here gets hidden away. Come on. Like it's all right inside there, right? That stuff I copied out. This guy, that logic is happening to give us this scratch pointer. Once we have the scratch pointer, this can take over. So we don't have to worry about like if they have like interesting types like arena temp or something. We just know that if they're asking for a get scratch implementation, that get scratch implementation of that library is already like aware that the library has some kind of arena pointer thing. So we just have to build the bridge to how their get scratch works for that library. And so if we want this, it could be like arena md get scratch. So the next part that's weird is that these become the wrong type again, but these are all void pointers, right? So it seems like maybe I'm getting the impression that like doing a pre-bridge setup is gonna be a lot better. So like, let me undo that. I didn't mean to make these changes real. I'll give that a minute. Okay. So it seems to me like what we're going to end up wanting is that like this part here has to go up here. So when we go to include the library, we turn off the defaults in a like a pre plugin way, like we define ahead of time rather than after the fact what the arena type looks like. You could even say that it looks like this now. So there would be no typedef MD arena, rather MD arena is a macro that you're supposed to define to a particular type if you want it. The default arena definition moves into the header, and then when you do that, you're saying like don't set up your own thread context type. Default thread context. But if you want to, you set up thread context default, thread context, thread init default, right? So like this becomes the API. You only have to call this from the Metadesk code base or library if you're like dropping the Metadesk library in and making it work without a full code base, right? If you're just making like a quick helper program or something from the ground up. But if you're within a code base, you disable the default thread context. None of this even gets defined, and you don't bother writing it because like your code base already has a thread context and a thread init or whatever, right? You already have this part, and so then all you have to do is the impl get scratch. I think this is just the right path for doing these kinds of things. I don't know. All right, I think I've thought that stuff through enough. So I'm gonna save that, and let's try to like conclude all of this now. So my biggest findings are I prefer. Let me do it this way. Avoid function pointer based overrides. Prefer macro based overrides. Macros allow you to define one override per compilation context, but that one override has better range than the kinds of overrides you can do with function pointers. You can always use macros to plug in a dynamic dispatch system, but you can't use function pointers to plug in high-speed, lightweight systems. Okay. 2. It's starting to seem like the header technique is the way to go. It solves a couple of problems for the, what's it I'm looking for? It solves a couple of problems for the, library, which won't know the size of the arena struct. When it is written. And there are good enough bridge techniques for libraries that have non-header arenas to get up and running, and fixing the remaining issues shouldn't, or fully transitioning to header technique shouldn't be too hard. Okay. Third lesson. It seems like it will be better to count on pre-bridging at least the types and default controls before the header so that we can get type checking on various arena and array of arenas parameters. This idea was less fully explored. It may still turn out to be better to stick with post bridging. Okay, so I think those are the biggest things I have takeaways from for today. So I'm going to save that, and then I kind of want to also grab some of these to-dos. Should we do this style? I don't think I want to go with those, but like test integrating two libraries into the same code base. Haven't done that part yet, so these are good. Could there be an easy bridge from a malloc-free style allocator to an arena style? In the code base to an arena style in the library. Thread context. Okay. This same idea should work for thread contexts. There we go. Can save my to-do so I know where I want to pick up next time I'm working on this problem, and I've got some of the ideas written down. Probably writing them down is all I'm going to need to remember them forever, but I don't know. Putting in a little bit of effort to get organized sometimes helps in all kinds of ways. So hopefully that was useful. Back to chat. Looks like chat's been pretty slow, which is fine. It's been 3.5 hours now, so I'm about to wrap it up anyways. So I don't know if anyone has stuck around to see us get to the end and is just not being chatty. But if you're there, thanks for hanging out. I'm signing off now. Later.